Good afternoon, student. This is a pipeline hazard. Pipeline hazard means the stage of a pipeline can wait for a previous instruction. Say I1 and I2 are two instruction. Then I2 can wait until finish the I1. Such type of situation is called the pipeline hazard. Okay. See the type of hazard. First is the structural hazard. Structural hazard means when a unit say unit 1, unit 2, unit 3, unit 4. Okay, unit 1 is the phase the instruction, say unit 2 is the decode the instruction, phase 13 is the phase the operand. Okay, phase the operand and phase the instruction, phase the operand, phase the instruction, both operation are used to fetch the data actually. So that means that when the in this fetch time is this fetching time, the address bus and data bus are used. Okay, so if you consider that another instruction is start from this place, that means when the first instruction is executing the phase the operand, at the same time the phase the instruction can want to perform by another instruction I3. Okay, but the address bus or data bus is a single bus, so we cannot start this I3 from this place. That means fetch instruction cannot perform in this time. Okay, that time so we can we can execute I3 after finish this unit, this fetch operand unit. Okay, this is the structural hazard. Okay, next data hazard. Data hazard means that data can be wait for the previous data. Say consider a is equal to 2 plus 3. Okay, b is equal to 3 plus a. Okay, that means say it's I1 is I2. I2 can wait for the I1 because a can get the result by using 2 plus 3, and b will use the result of a previous a. So until finish the I1 we cannot get the value of a. So instruction 2 I2 can wait for finish the I1. Okay, that type of situation is called the data hazard. Okay, and the when the that means the is a write operation, it's the operation and result will be right at the a, and it's a read operation, that means value of a will be read. So in this called is a write after read. Okay, write sorry, a read after write, read after write. There's a read operation can be performed after this write operation. Okay, so is a read after write. Okay, next is a write after read, write after read. Okay, say consider the instruction 1 use 5 data. This this instruction 1 use the 5 data, and data 1, data 2, data 3, data 4, data 5. This 5 data will be read, and the data instruction 2 using execute only one instruction to write the fifth data, is it to write the fifth data. So until read the fifth data by this I1, the I2 must wait for the write operation, is the read after write, is a write after read. Okay, next third one is the write after write. Write after write is a if say I1 execute this part and I2 execute this part. Okay, the write operation can perform this part, and write operation can be performed always this part. That means the write operation of I2 can be execute after the write operation of the I1. Okay, this is next a control hazard. Control hazard means if condition satisfied, then this part ends this part. That means until finish this if instruction, we cannot decide the whether this true statement will be executed or false statement execute. So until finish this if statement, we cannot going to the start for the next instruction. So it's a control hazard. This control logic can be control logic can decide the next instruction which will be executed. Okay, so is a pipeline stall. Okay, pipeline stall, that means when the stages, when the next instruction is I1 and is I2, when the I2 is wait for the next part, next execution, so this time is waste, and this is the called the pipeline stall. Okay, so this is the everything for the pipelining, student. If you have any doubt, then we will discuss this doubt in our doubt clearing classes. Okay, thank you, students.